You have never truly seen yourself in the glass. Your reflection does not live in the glass at all. It hides in a metal skin behind it, thinner than a bubble. This is how mirrors are made, from plain glass to a perfect reflection. If you love interesting facts, your mirror is lying a little. So where does your reflection actually come from? Pick up any mirror and it feels like solid glass. But the glass is only a clear shield. The real work happens on the back of it. A thin coat of metal is pressed against the rear. The shiny side you face is just a window. Everything magic is hiding behind the pane. The glass alone could never reflect you. That hidden metal is usually silver or aluminum. It is spread in a layer stunningly thin. Picture a sheet far finer than a human hair. Split that hair 1,000 times over. That whisper of metal bounces back all the light. Your whole reflection rides on almost nothing. A ghost of metal does all the work. Think about the journey your face takes. Light leaves you and strikes the mirror. It slips straight through the clear glass first. Then it hits the metal and bounces sharply back. It races through the glass a second time. Only then does it reach your waiting eye. Your reflection makes a tiny round trip. A perfect mirror needs perfectly flat glass. Even a tiny ripple would twist your face. So the glass is made in a strange way. Molten glass is poured onto a pool of liquid metal. It floats there like oil resting on water. The surface settles dead flat as it cools. Your mirror was born floating on liquid tin. So how's metal get onto the glass? It is not glued or hammered on. A special liquid is sprayed across the surface. Inside it, real silver is hiding, dissolved away. A second chemical makes the silver fall out. The metal settles into a smooth mirror skin. Your reflection is grown by a chemical reaction. That silver skin is shockingly delicate. One scratch and your reflection would tear open. So the back is sealed with tough paint. The paint guards the metal from air and damage. Air alone would slowly eat the bare silver. That dull backing is a quiet bodyguard. It keeps the magic from rotting away. Something nags at my curiosity while I write this. This same silver trick is done all over the world. A grand mirror workshop in Italy, a high-tech plant in South Korea, a busy factory somewhere in Germany. I am quietly wondering which country you are watching from right now. The country, not the city. And wherever you sit, your mirror hides older secrets, because people chased reflections long before glass. Long before glass, people still found their faces. The first mirror was a calm pool of water. Then someone polished a dark stone until it gleamed. Ancient people even shined slabs of volcanic glass. Others buffed sheets of bronze to a soft glow. These mirrors were dim and easily scratched. A clear reflection was once a luxury. Before silver, mirror makers used something deadly. They laid a sheet of tin over the glass. Then they poured shining liquid mercury on top. The two metals fused into a bright reflective skin, but the fumes slowly poisoned the workers. One famous island guarded this secret like treasure. Its makers were trapped, and leaking it meant death. Not every mirror hides real silver inside. Cheaper ones use a skin of aluminum instead. Silver throws back the brightest, truest reflection. But silver tarnishes and slowly turns dark. Aluminum is duller, yet far tougher over time. So your bathroom mirror is a careful trade. Beauty on one side, endurance on the other. A mirror follows one strict, simple rule. Light bounces off at the angle it arrives. Come in steep, and it leaves just as steep. Come in shallow, and it slides off low. Nothing about the light itself is changed. Only its path is neatly folded back. Order in means order out. So picture two ways to make a shiny surface. You can polish a metal until it gleams, or you can back clear glass with silver. Which one gives the sharper reflection, metal or glass? One word: metal, or glass. Write it below. Bend a mirror and reality bends with it. Curve it inward and it magnifies your face. Lean too close and your face flips over. Curve it outward and the whole room shrinks. That is the trick of a funhouse hall. A flat sheet of glass warps your body. Shape decides what the mirror shows. You meet a curved mirror every single day. The side mirror on a car bows outward. It squeezes a wider view into a small pane. That is why traffic looks oddly far away. The warning printed there quietly admits the trick. Objects are closer than they appear. A curve buys you extra sky. Some mirrors let you spy right through them. Their metal skin is left thin and patchy. It reflects some light and lets some pass. In a bright room, it acts like a mirror. From the dark side, it becomes a window. The trick is not the glass, but the lighting. One pane, two very different worlds. The finest mirrors point at the stars. Telescope glass is curved and coated with aluminum. Its surface is polished beyond belief. Scaled up to a whole country, its bumps would be tiny. A stray fingerprint could blur a distant galaxy. These mirrors gather light from the edge of time. Perfection here is measured in atoms. One space telescope wears a stranger coating. Its giant mirror is covered in real gold. The gold layer is thinner than a soap film. All of it together weighs only a handful of grams. Gold reflects the faint heat glow of the cosmos. So a golden eye stares into deep space. A mirror plated in treasure. Some telescope mirrors are not solid at all. Picture a shallow dish of liquid metal. Spin that dish slowly and steadily around. The surface curves into a flawless, smooth bowl. That spinning liquid becomes a giant mirror. Astronomers have used pools of Mercury this way. A whirlpool of metal can watch the sky. The best mirrors on Earth hold no metal. They stack dozens of ultra-thin see-through layers. Each layer nudges the light back in step. Together they reflect almost every ray that lands. These mirrors steer the beams inside lasers. Barely a sliver of light escapes them. Near perfect, built from clear glass alone. Now picture a desert covered in mirrors. Thousands of them tilt to follow the sun. Each mirror throws its sunlight at a distant tower. All that light piles onto a glowing peak. The heat there can melt metal with ease. A field of mirrors becomes a furnace. Reflections hot enough to boil salt. No mirror ever bounces back all the light. Each reflection quietly swallows a little of it. A good mirror loses only a small share. But nothing shiny is ever truly complete. Some light always sinks into the metal. Every bounce comes back a touch dimmer. Perfect reflection is a beautiful lie. Here is a stranger thought about your reflection. The light must travel to the glass and back. That round trip takes a sliver of time. So you never see your face in the true present. You see it a tiny moment in the past. The mirror shows a version already gone. You are always chasing a slightly older you. Here is the twist that fools everyone. Raise your right hand at the mirror. Your reflection lifts its left, or so it seems. But the mirror never swapped left for right. It only flipped the world front to back. You turn the sides around in your head. A mirror reverses depth, not your hands. And here is the secret color of every mirror. A mirror is not perfectly colorless at all. The glass drinks a little of the light. It swallows red and blue more than green, so each reflection leans faintly toward green. Stand between two mirrors and watch the tunnel. The endless hallway slowly turns green and dim. So look into your mirror one last time. The glass is only a shield, not the magic. The reflection sits on hidden metal behind it. It comes back slightly dimmed and faintly green. It flips your depth and fools your mind. You have never seen your face in the raw, only a bounced, tinted ghost of it. I still cannot get my head around one of these. that this endless tunnel between two mirrors slowly turns green. Which fact surprised you the most?